Sung, you'll be up next here, and another new feature inside Mathematica 9, a very exciting new feature, was RLink.
Right. Okay, so I will talk about this RLink and integration with R within Mathematica using RLink. So let's take a quick look what we are talking about here. It's just a very simple example to give you a taste of what we are talking about. So first of all, when you try to use the R with the Mathematica, what you should first start with is need the RLink, or the more experienced users would know, you can do this. Of course, you already did it. So after doing that, the first step is to install RLink, install R. So what it does is that if you don't have a R installed on your machine, it automatically grabs it and installs it for you. But in my case, it's already in there. So let's say I define just a range 1 to 10 variable to the A. And the R set is a simple function assigning this particular variable A into the AA, in this case AA, in R. So, what essentially it does is that send the data of the A to the R. So now the R knows the definition of that AA. Now, let's try also single just line evaluate, just like when you're typing the lines in the R. So R evaluate a command for that. So you can say BB assigning 1 to 10. It's similar to Mathematica range command, and you are getting the answer back to the Mathematica automatically. And now, since I send the AA to the R already, I will try the type of AA, and it'll answer one of those defined types in R, in this case integer. And then, well, I want to see the value of R, then you can evaluate that string. Now, also you can use your own function in R. In this case, I will define function x, which doesn't do anything except securing the variable. And then good thing about this RLink is it's completely integrated with Mathematica. So you can use our function as if it's a Mathematica function. You don't have to any conversion and things. So see, you can just feed it too, and you get number 4. And you will notice that it's returning as a double because the default type for the R is the not integer type. And then you can assign the A. In this case, it's actually sending the Mathematica variable A to the R. Then it gets to this defined function, and you get the answer for that. Also, you can directly use the AA that's already in R using the R evaluate, and it gets that variable from there and then evaluate it. So this is a very quick example, and I will go deeper later. But I will start with this. So what does the RLink do? First of all, I'm sorry I didn't mention what R is. So I hope that most of the people are interested in this R already knows what R is. R is a open source language for the statistics. It got very popular since 2005, and it's had a lot of activity around that language R. A good thing about R is it's a very community-driven language, and they have like more than 400 packages around all these areas. So what RLink gives you is the exchange data between R and Mathematica. It's as you can see, I demonstrated, it's very fluid. It's very seamless within the Mathematica. Also, another thing is the R provide a very specific code to do some very application-oriented statistic functions. If you found those, or you're already in R programmer and you have some bunch of R code, you can execute those R code within the Mathematica without very seamlessly. And another one is this is more bigger one than everything else. So what this RLink eventually gives you is the ability to combine the workflow in the R and the workflow in the Mathematica in a single workflow, so that you can get a benefit from both of the command. Both of the word. Let's see. So why RLink? Why do we care about this RLink? So probably a lot of people here are already familiar with the MathLink and JLink, all these linkage technology from the Mathematica. So this is a latest addition to the Mathematica's connectivity technology. So it follows our framework, how we handle the external languages within Mathematica. What it gives you is full access to our functionality within Mathematica, especially given the fact that R is evolving around the community and it has a lot of application-specific functions, especially in biotechnology or finance. You might be able to find some of the functionality very, specialized function that you might not be able to find in Mathematica. You can just grab that and use it without any, problem. And another thing that the Mathematica provided here is you can use Mathematica as actually a very powerful development and testing and also visualization and eventually deployment environment for R. It's slightly different from the just a regular, integrated development environment, such as I believe R. In case of R, they have a R Studio. It's slightly different because Mathematica not only provides just plain text editor type of environment, but also it provides a lot of different functionality. That's what my fifth point. So not only you can just use the R statistic functions, you can also utilize the Mathematica's built-in functions like manipulate, dynamics, and all these thousands of functions across all the area. For instance, image processing that we just showed. And also you can combine Mathematica's high-performance, highly optimized symbolic numeric functions, such as if you talk about like a linear solve. R Pro has its own linear solve, but the community version, the open source version, doesn't contain highly optimized the library for that. And for that purpose, you can actually use Mathematica and use the Mathematica's power. And if you find some other functionality in R, you can just send that data back to R and process it and get it back. Now, the point of this is that if you're a traditional R user and you are interested in Mathematica, definitely it's a great tool to make a transition from the R to the Mathematica. So let's take a look at how the RLink works in detail. As I said, we start with the downloading the package, the RLink, and then the first thing you want to do is install R. So it does two things. If you don't have already R installed on your machine, it grabs it automatically from Wolfram's data packlet server. So that means it guarantees you're getting the certified version that's compatible with the RLink. And when you do that first time, what you are seeing is this quick pop-up saying you're supposed to install RLink, and it is commands the download, and it takes that long time. The package is not that big. Once you're done with the installation, of course I already installed it, you can check the version of the R using this is R command, so R.version, then it tells you a bunch of information about the current installation. For instance, if you want to just take a look at version number, then you can just put the property version, then you see the R version 2.14.0. That's what got installed here. So also, if you for some reason the R installation doesn't go on, or it didn't succeed, and then you can manually try to install it using this RLink resource install. Of course, in this case we already have it, so it just tells you that it's already being installed. And then if you this one is kind of a dangerous command. I'm not going to evaluate it, but this essentially what it does is it's uninstalling the R packages that Mathematica downloaded and stored in it's the system directory. Now, uninstall R just means it doesn't do uninstalling of the whole package. What it does is it's unloading the current R session, the client, so that when you do that, what's happening is if you have any variable that's stored in R side, it's gonna be deleted, and you can start freshly using install R again. So that's what it's happening. Now, there's a question about, well, I'm already using R, and I just want to utilize the R installation that I already have. The answer for Windows, we do have an answer. So, you have a command install R, and there's an option value. The R home location goes to the particular location that your distribution is being installed there. Make sure that your R distribution include the shared library there, so that the Mathematica can load that one. There's a solution for the Linux and the Mac too, but we'll discuss that in Q&A. Now, let's start with a very basic step, how we're going to exchange the data between R and Mathematica. So first thing you have to know here is that Mathematica has a lot of different types, but unified as an expression, right? So the R doesn't have the wide range of data, the representation. So there is a little bit of compromise. There's things that you can send to the R, and there's things that you can't. So let's just start with again the same command. So the first step, R set is a command that I'm sending any expression. It could be a number or just a regular expression, whatever. Sending it to the R and assigning that to the AA. It is actually equivalent to the evaluate AA assigning 10. So, of course, it's just slightly different in this case because in Mathematica case, it automatically typecasts to the integer. In our case, it doesn't do that. So let's see, I did this. and see the types, and it says integer, right? Also, it's not just only numbers. I can assign a list of numbers like this. So a list, if I see the content of the a list in the R side, now it's having the list of a number from 1 to 10. Now, you can receive the data from the R2, just like what I did. So when you just type the AA, you're getting the 10 back. A list, you're getting this number back. And the fascinating thing here about it here is that you don't have to do any conversion process. Mathematica knows what type it is getting, and it actually put into the form that it's understandable in the Mathematica, other Mathematica functions, so you can just directly use it. Now, another one is you can also assign the variable and get the variable directly to the Mathematica. So the difference here is this. So if you just do this, let's say without assigning, you just evaluate. What's happening here is you're getting the number back to the Mathematica, but that particular list of 1 to 3 is not being stored in R. So only way to access it from the Mathematica. Whereas if you assign it and get it, then you're having the number in both ways. So you have a B list defined in R side. Also, you have this list of numbers defined in the Mathematica side. You could assign different things too. For instance, the matrices, in this case, Mathematica's Gaussian matrix 1, which probably is 3 by 3 matrix. I'm assigning that to the Gauss. Now, what I can do is just like R's assign command, you can partially assign. In this case, first column, first row, I want to change it to the 0, 0, 0. So that's what's happening, and I see the contents of it again. Then, as you can see, it's partially assigned in the first row. So let's move on to the slightly, advanced topic. So what kind of data type is being supported in this RLink? So first, the things that I already showed you, the list type and matrix type of numbers, integer and doubles. And of course, it's just machine precision numbers, unlike the Mathematica. R doesn't support the arbitrary precision, so you are limit to the using the machine precision numbers. Also, the notion of the list, it's just a flat list. In R's, the word, they call it the vectors, and the matrices are supported. Also, you can assign the ragged list, just like this one. So it has just varied lengths, 1 to 5, and you can just assign into the particular variable. Also, there's a different native types the types that's native to R. One is a string type. In R, that's called characters. So I'm assigning a list of characters here. So I'm using string split. I'm assigning that, and check out that variable that's being assigned to that particular characters. Then this is a list of characters. Also, the Boolean values in Mathematica side, which is also called in logical values in the R side. So you can just assign the true and false values. In this case, random choice with true and false, and it says it's a logical value. And you can do a combination of any of these. So, this variable combi contains all these different type numbers, variables, and these strings. Now, actually, there's an interesting thing about when it comes to the assigning is that R support the attribute to the this data structure. And in the later on, I will talk about this more, the expanded version of it, something called data frame. And then you can easily assign this attribute to each object using the R object and R attribute command here, just like that. So instead of just setting the variable obj in R side with the range of number 0 to the 1 to 9, what I'm doing here is it's a R object, and I will describe what this R object and R attribute mean in the later on, and assigning one of the attribute of the R object, which can be a dimensions, as a 3 by 3. So let's see what's happening here. So this is a return form of that R object in Mathematica side. And if I evaluate that OBJ in R side, what you're getting is the matrix out of this, is the number 9. And as you notice, the matrix notion is slightly different. This is kind of a transpose to the what Mathematica do. Now, let's move on to so we now know how we can exchange data between R and, the Mathematica. Now, how we can call the R's code or R functions from the Mathematica side. There's a simple examples here. So already I showed this command R evaluate, which shows the numbers like this. So essentially what it does is it's just like you typing this particular string in the R command, the R console, and you get the answer. Of course, you can use the various this the statistic functionality that I already have. So in this case, I'm getting a mean of this list of the number 1 to 10, and also I can. In this case, I'm getting a uniform 20 uniformly distributed numbers ranging from 0 to 10, and you get these numbers. Now, here's the one thing that I mentioned before. If you just evaluate like this, the output result is just sending to the Mathematica, and running R behind the scene doesn't know about this value anymore when it returns the output to the Mathematica. So what I mean is that if you evaluate the uniform, which is actually the Mathematica variable here, R doesn't know about it because it's not R's notion. Now, to avoid that, when you want to keep, if you want to keep the copy of the variable input in between both the Mathematica and R, what you can do is you're assigning it here like this, and also doubly assigning it here in the outside, so that the variables are living in both in the R and Mathematica too. Now, you can also do the multi-line evaluations pretty easily. Only thing you have to remember is wrap things around with these curly brackets, and just using the line breaks to make the multi-lines. In this case, assigning variable A to 1 to 10, B to 10 to 15, and 13 to 15. Create a list, essentially joining these all three lists and getting a sum of it. And as you can see, you can get the answer. And one of the points that I made at the beginning why you were careful about RLink is that the Mathematica can be used very good verification and testing tool for the R, because a lot of Mathematica functions are written very mathematically correctly using symbolic computation. So in this case, you can easily check that it's exactly the same thing that doing in Mathematica. So you can confirm that answers are exactly the same. Now, the real fun thing here is you can build up your own functions in R and just grab it and use it in Mathematica as if it's a Mathematica function. So in this case, I'm going to assign a function. So why don't I start with okay, let's start with that. So in our side, I'm defining fun as a function, which only thing it does is just carrying the number and getting that pointer to that function to the assigning, and assigning that to the F. And the F gets is the R function. The close is a notion, the object notion in R. So what F has is it contains a pointer to the function that is defined in R. Now, how are you going to utilize that function? Well, this is just a kind of a dumb way to do it. So you just use it within the R like this. But it's not that exciting. So what we want to do really here is using this as if it's a Mathematica function. So let's again assign an F, but instead assigning fun with the in our side, I'm not going to assign that. Now, what's happening is that the pointer to that particular function, the reference to the function, is associated with that F in Mathematica side. And you can just call this F with the any Mathematica expression, and R will do, if there's a conversion variable, the valid conversion, it will do whatever computation it's supposed to do. So in this case, you can just pass the list of 30. Or another way to referring this, the particular function is using R evaluate this fun, because if you do this, because I already assigned this function on top of the line 52, what you're getting is a returning form of the reference to this R function. So you can do this and using that particular argument to that function too. Now, this is not preferable way for us because it could bring some confusion between the object and the function, the point reference. So the preferable way to do it is using R function command and calling the function. What's happening is instead of returning, getting back, and returning back, it's actually just directly going to the function reference to the R and pass this variable to it. And again, you can combine this with any other Mathematica functions. For instance, you can do the scale of the Gaussian matrix using just this. Now, and I'm trying to confirm that whether it is actually same as what you are doing in the Mathematica side, and of course the answer is true. So I can do this and take a look at it. And of course, you can utilize this to visualize this within the Mathematica, just like that. So as you can see, it's a very seamless. And if you're familiar with, for instance, CUDA link and the OpenCL link and other linkage technology we brought up last year, with the version 8, it's quite similar frame, and it's pretty easy to use. Now, I will go over some interesting examples. So in this case, just using the R's own function to process a text. And in this case, using the split function to essentially so I create a split function and use that function as if it's a Mathematica's function, and pass it with the text. And what you're getting is our object with the frequency, the location of the each word and the attribute as a names. And so it means the end is happening in 25th place and so forth. Now, this is not that exciting example, but we will move on to the more complex examples from here. Now, as you notice here, we have a bunch of these, R code, R function, or some R object that represent the object from the R within Mathematica. It's because, as I mentioned, that the R and the Mathematica has a slight difference between how they represent objects. So this is over, schematics, how we are converting this R object with our own. So for instance, the characters, logical, complex, double, and integers, that's native R formats. And that's getting into fitted. So when you call for instance, the list of the vector, like the integer list of integers, that's get as a R vector with the native type integers, and that's fitted into the Mathematica, and we can communicate it back and forth. So to confirm what kind of representation you have, it's actually technical details that you don't have to worry about most of the time. So as I said, integer values in presentation in Mathematica side looks like this, but when actually Mathematica gets it, it already converted to the form that Mathematica other functions can understand, just like a plain list of integers. Let's get over like 3 examples, more exciting examples, and stop this, talk about R. So one unique thing about R is they provide something called data frame. So data frame is it consists of the not only data, but also multiple data and the meta information about that data, like the column, row, what kind of information they want to have on the data, and using those information, they can easily filter out the object from using that particular field. So in this case, what I'm trying to do is assigning a numbers range from 18 to 23 and list of heights and the list of names and creating a data frame out of it. And I'm just using as data frame the R command. What you're getting from here is R data frame, unlike the R object they used to get. In this case, Mathematica actually knows what type of data it is. So it has an R data frame, and it has the R factor, which represents this the meta information associated with this particular data. Also, the table form, excuse me, understand the R data frame. So when you just do the table form of this R data frame, it actually puts these, the column and the labels and the row labels in appropriate place like this. Also, you can use our filtering functionality just like this. So I want to filter out any data which has a height value greater than 78, and you can create a subdata, which is also written as a data frame, and you can actually confirm that data. And I will show you then at the end how to use this combining with the manipulate to another interesting thing. And then, so this is how you get, it's the same version, so let's go over. Now, sometimes one of the actually compelling point of using R with the Mathematica is Mathematica can provide a lot of different type of visualization. I mean, R also have its own packages, but I believe Mathematica has more than what R can provide. And also R's functionality, the Mathematica's functionality, especially in the visualization, which I think later on, Brad will talk a little bit more about that, contains a lot of specified functions that you couldn't find in the R. So, but this is a kind of odd case. There are like, number 1 or 2 functions that the visualization function that Mathematica is not doesn't have yet. I said yet because we will probably have it in the future. So in this case, it's a one way to communicate the creator graphics in the R and grab that visualization to the Mathematica side. And in this case, we are using a PDF format as an intermediate format. And we choose the PDF because it's more universal in all the platforms. So this function is just a not dummy function, but kind of meta function, which you pass the plot and the file name, and then it'll create a output of that particular plot and save it as a PDF file. And this is a wrapper function on top of that. We use our temporary directory and create a temporary PDF file and call whatever R's plot function there is and grab that. And let's see how it works. So in this case, instead of assigning any particular function, I just directly send it. So the x-axis consists of number 1 to 10 in 0.1 increment, and then the y-axis is just sign values of that, and create a function plot of association of those two. And you can see, you can directly get the answer from the R just like that. But of course, as a Mathematica user, you know that, Mathematica results is much more preferable here. Now, this is one of those examples that Mathematica doesn't really have as a built-in function, hierarchical clustering function. I believe we do actually have a standard package for that, but it's just data package. So, it's a showcase. So we create a random variable. It's a nice showcase to how you're going to combine Mathematica statistics functionality, especially the things around the random variables. We have a very extensive list of the random variables and distribution we support. Using that, you create a list of random variables assigned to the y, the values in R, and you evaluate. This one is just adding a label to those particular data sets. So it's just adding the proper attribute to the object. Now I evaluate and create a correlation and the distance matrix out of this, which is done in here, and using the hierarchical declustering function in R to create a plot function. So I draw two flow functions, then you can see that Mathematica nicely grab the answers from that. Now, the last example is how you're going to use it. This is a very compelling example because I think it's a pretty strong point here. I'll provide also, the way to create your own, graphical user interface and such. But you know that Mathematica is a really simple way to create these lot of interfaces, such as manipulate. It's just too easy to pass. So, it's a way to combining the Mathematica's functionality with our functionality and, completely seamlessly using these two work together. So this is our developer Leonid grabbed information from the Stack Exchange. This is the statistics on the beta sites on the Stack Exchange. And I will describe what all these numbers mean. And here I create a temporary directory to store that particular data. I could have just sent it to the R, but to make it a little bit interesting, I'll send it as a data, the file, and pass the file name to the R, and using R's function read.table to read up that particular, the table, and associate names, the column names to the particular data set. So first column is name of site. Second column is a question per day and question answered. ABD users, they have this metric to measure how the active the users are, and the answer ratio and the per visit, the visit per day information. We associate that here. Now, let's see in nice form how it looks like. And I use the head command in R to show just a first bunch. It's not showing all data. Now, I create a filter function in R. You can of course do it in Mathematica. Just to make it interesting, I want to do it in the R. So I'm passing criterion like a variable like 1, 2, 3, 4, 5. So the order by and each criterion, what kind of filtering I want to do in each area, like a question, the query for day, be the users and the answers and such. I create that function and assign the reference to the function to this particular Mathematica function. Now, this is all it takes. You call this function using these different variables, and you create interface. If you're familiar with manipulate, you know what it means. So the range and the initial values, and boom. What's happening is you just create a nice interface on top of the R function. You can, choose to sort by all different, the areas. You can filter data by the particular value like this. And as you can see, what's happening here is whenever you change these values, Mathematica instantly calls R in the behind and to get the variable and displays on the Mathematica side. So as you can see, this provides a lot of good functionality to the Mathematica users. So for the Mathematica user, it's like you're getting a lot of help from the R when you find your relevant function in R. Also for the R users, it provides not just gluing language like any other language like a Python, which doesn't have anything except just doing the gluing of other languages. It provides a lot of different functionality like a dynamic interface, the graphics and the connectivity to other languages and the database and such, and the easy way to grab that data. So it's kind of providing an army of functions to the R, and it'll make your the work more productive in this sense. So that's about it.
All right. If you want to learn more about RLink or find some examples or sample code, head to the Documentation Center. You can also head to wolfram.com/Mathematica.